Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about the scary theorems of calculus. So you may have seen these, and you probably see these in your textbook where they say focus on theory or proofs, and they kind of get messy and confusing, but we're going to talk about them, hopefully make them a little less scary for you. So first we're going to talk about the extreme value theorem. So what that says, and I'll read the formal definition and I'll explain it a little bit more. That says, if f is continuous on a closed interval, AB, then f has an absolute max and an absolute min at some numbers in AB. So all that's saying is, if you can draw a function and not pick up your pencil, showing that it's continuous, then there has to be an absolute max and an absolute min. Kind of makes sense, because if you draw a function, if you obviously have to stop going up at some point and stop going down at some point. So with this, let's just check here real quick. So for this example, the absolute max actually occurs here at this point. And that we'll call C. And similarly, here at this point, this has a min. So we'll call this D. So what this says is, once again, if this is continuous through this entire interval, then there has to be a max and there has to be a min. So the maximum value is actually f of C, and the absolute minimum is actually f of D. Now, if you notice, you may have talked about things like local min and local max. Sometimes those will actually be the absolute max and absolute min. Kind of makes sense. So to check for these, you would need to check the local mins, the local maxes, and the endpoints. That's how you check for global max and global min. All the extreme value says is that they have to exist, which kind of is intuitive now. So with this one, here's just another example I'll show. They can also be the endpoints. So for example, our maximum is actually our endpoint, A. So the maximum, f of C, equals f of A. So we have, once again, our global max, or our absolute max. The absolute min, once again, falls at a local minimum, so f of D is our local minimum. So that's just some examples of the extreme value theorem. So the second one that we're going to talk about is the mean value theorem. So that says, if f is a differentiable function on the interval a to b, then there exists some number c between a and b such that its derivative equals the slope between the two endpoints. Okay, so I'll read that one more time. This right here is actually what I just said. The derivative at that point c is equal to the slope between the two endpoints. I know this function, or this equation, excuse me, looks kind of messy, but it's actually all it's saying. If we took the slope between the endpoints here, then there's some value in between here. If I take a tangent line of, it's going to be the same slope, which actually that's the example right there. So that value c, as we've shown, has the same derivative, or excuse me, has the same slope as the slope between the endpoints. And once again, I'll show an example here. In this case, it only had one value c. That's not always true. There might be two or three, but there is at least one. So in this case, if you see the slope between these two is right here. So at this point, maybe right there, and maybe at this point right here. There's two values of c that have the derivative equal the slope between the two endpoints. So that would be like c1 and c2. So it can occur multiple times. So that's the mean value theorem. So let's talk about the last one, the intermediate value theorem. What that says is, if f is continuous on the closed interval a to b, and n is any number between f of a and f of b, where the values are not the same, f of a does not equal f of b, then there is a number c such that f of c equals n. Okay, so now let's look at it so it'll actually make sense. So what this says is, if we have this continuous on the closed interval, which has been the same for all these, we can pick any number between f of a and f of b. So I can pick any number here, is what we're saying, any number n. So I'll just pick it right here. What they're saying, what this says, the intermediate value theorem, there has to be some number here, some c, that if I plug it into the equation, it will give me that value n. So as you can see, this is similar, this actually has to do kind of with the horizontal line test, you could call it. Right there, and right there. So there's right there three values, c sub 1, c sub 2, and c sub 3, that when I take this and that, I'll actually get n for all those. They all equal n. And that's just because you can pick any value in there and get that value. Similarly, I could pick n right here, and then I would get 1 right there, and things like that. So that's all the intermediate value theorem says. And that's one example of it. So just if it's continuous, then you can pick any value n, and there has to be a c value to go with it, or an x value. So that's been an overview of some of the confusing and difficult theorems of calculus. I know it's been scary. Hopefully it's cleared it up a little bit, and we'll hope to see you next time.